All right, hello and welcome back to First Saturday Science. My name is Alyssia, and I'm so excited to be here with you today. I'm even more excited to be able to have a face reveal since you guys haven't been able to see my face for half of our videos. So I'm really excited. This is what I look like. This month is the month of May, and we're covering the lithosphere. So if you didn't know, we're going to do a quick recap. The Earth has four spheres, actually five, but for the sake of this video, we're going to talk about four. It has the biosphere, the atmosphere, which we covered last month, the hydrosphere, and the lithosphere, which we're covering this month. And in the lithosphere, there's actually about 7 different layers, but we're going to talk about 3, which is the core of the Earth, the mantle, and then the crust of the Earth. And a lot of activity happens in the lithosphere, believe it or not, and it's all the way underneath our feet, very, very, very deep. Tons of activity happens, like earthquakes or the formation of volcanoes, which we're going to be doing an experiment on volcanoes today. And one thing that most people don't know about volcanoes is that we get to see them spew, but a lot of the activity happens, or the creation of them happen, in the lithosphere. And actually, 80% of the Earth's landmass that we have today was all created by volcanoes and the activities of volcanoes. So we have volcanoes to thank for a lot of the Earth or landmass that we have today. I'm going to pass things over to Antavia and our little scientist Dakota, and they're going to get into more information about what we're doing today. And I'll see you in a minute.
Hello, welcome back to First Saturday Science. Once again, I'm Antavia and this is Dakota. So today we're going to do an acid-base reaction experiment to kind of mimic the process of a flowing volcano. So even though the way that volcanoes erupt isn't an acid-base reaction, some of the principles physically are kind of similar. And so for this experiment, in our First Saturday Science take-home tips, you're going to have a little information packet. We're not going to use this today, but it's always interesting to have some extra information. And I would definitely recommend that you check out our other videos, like how to make a water filter in a bottle. Yeah, I know, it's really cool. And then soil permeability, we can go into it. As well as one of the seismic activities. And so also in the kit, you're going to get your little lab procedure. It's going to have the date and take home, and then an explanation of what kind of experiment this is, which is an acid-based volcano experiment. And then on the inside, you're going to have your materials list. And for this month, we have a test tube, and the test tube contains vinegar in red dye. So this is red vinegar. The main ingredient in vinegar that we're utilizing today is an
carbon
acid.
dioxide.
No, what's the acid? Acetic acid.
Oh, yeah.
It's okay, it's early. And then you're also going to have our base compound. So this is our acid compound, this is our base compound. Do you remember what our base compound is?
Baking soda.
Baking soda, exactly. And then we're also going to have a little bit of kind of crafty playtime with our air dry clay. And your kit includes a terracotta colored clay. You can use any kind of clay, or you also don't even need to use the clay to make this experiment work, but it's kind of fun. And then you're also going to include a stirring stick, a plastic pipette, and a 100 milliliter beaker. And for those of you at home, oh, and you also should have like a little basin or some kind of bucket or bowl to put your experiments in, just because it's a little bit messy, unless you want to clean it up. So first we're going to open up. Exactly. I'll have Coda do this part because it's extra fun. So we're going to take out the clay. It is a little sticky. And then maybe I'll take half of it. And then you're going to mold it kind of into like a mound shape to cover your beaker. So I like to make kind of like a flat sheet shape, kind of a triangle form. and you're going to put it onto the side of your beaker and kind of press it on to make it look a little bit like a volcano. Oh, let it spinning out a little bit. Because you want it to be flat. And again, you don't need the clay to make this experiment work. It's mostly just for fun. And for looks, exactly. Alright, now that that's ready, you can kind of see our little volcano, it's ready to go. And now, for our next step, we're going to add about half of the baking soda into the beaker. You can just eyeball it, it doesn't have to be precise.
Did you say half of it?
Yeah, about half. It doesn't have to be exactly that. Something like that. In chemistry, we have something called stoichiometry, which is kind of like fractions or ratios. You use stoichiometry all the time in cooking and baking.
Yes.
And so the stoichiometry of a reaction kind of dictates how much of one thing to compare to another thing you need in order for that reaction to move forward. A good example is baking cookies. If you have like 10 cups of flour and you have 1 cup of chocolate chips maybe, and the recipe calls for 1 cup of chocolate chips for every 5 cups of flour, you actually have double the amount of flour that you need for that recipe, right? And so the limiting reactant in that experiment is chocolate chips. And something kind of a similar idea is the stoichiometry of this reaction is actually 1 to 1. So for every mole or every spoonful of baking soda requires the exact same amount of vinegar to react in the experiment. And so now we're going to see that in action. We'll open up the vinegar solution, the red vinegar solution, and then we'll take the pipette, and you're going to pipette some of that vinegar solution into the volcano. And I hope that you can see that little fizzy reaction, right? So that's just to give you a little bit of taste of what to expect for the next part of it. There we go. And so now we're going to pour in the rest of our baking soda. This is where the big reaction is going to come. Just so we're going to pour in all that baking soda to get ready for a big reaction. And now we're going to add all that vinegar solution, all of it. Whew. And sometimes you need to mix it a little bit to get it to react further. And there you have it. And the great thing about this too is you can reuse the beaker and the air dry clay. And if you have more baking soda and vinegar at home, you can do this reaction over and over. And I also, now that it's nice outside, I would definitely recommend maybe going outside with large amounts of baking soda and vinegar if your adults in your life are okay with that. And you can make a really, really big reaction. And it's a lot of fun. And it's actually pretty easy to clean, because if you add a little bit of dish soap to the solution that's left over, you actually have a really nice eco-friendly house cleaner as well. And we love recycling. So this is kind of a fun example of what happens when something is a little bit excited and really wants to move around. When there's so for this, I guess I would ask Dakota, what makes this reaction so big?
It's the amount, that's the quantity of carbon dioxide and the fact that it wants to escape.
Mm-hmm. And what is carbon dioxide?
It's a greenhouse gas that helps plants grow, and when plants absorb it, they push out oxygen.
Yes, exactly. It's a gas. It's a very useful gas in a lot of situations. It also is known as a greenhouse gas, which I would recommend you check out some of our atmospheric science videos. We talk a little bit about greenhouse gases and the atmosphere in general and how they affect the Earth. And this one, like Dakota was saying, all that gas really wants to escape. It wants to leave. It wants to leave all of the other compounds that are in it, and so it does that by like fizzing up. And you can kind of see that a little bit if you've ever had a carbonated beverage, like a carbonated water or a soda or fizzy water or sparkling juice. If you like shake it up really fast, all that gas, it's actually the same gas, carbon dioxide. All that gas wants to escape from that situation.
And so if you wait a long time and don't drink it and it's open, then when you drink it, it won't have any carbon dioxide.
Exactly.
So it won't be fizzy.
Yep, because all that gas wants to escape. It wants to leave solution. And so that's how, we start out with these little things like a little bit of baking soda and a little bit of vinegar, and it creates this big reaction. And that's due to the creation of that carbonic acid and then eventually that carbon dioxide gas. And something kind of similar is with actual volcanoes. You know how volcanoes erupt?
Well, when they overflow.
Yep, when they overflow. And what causes that overflowing?
Too much carbon dioxide.
No, not carbon dioxide. It's not the same reaction, but it's...
Well, when tectonic plates move sometimes.
Yep, that can definitely cause it. When there's some kind of kinetic energy added to liquid rocks, right? So like there's liquid rocks and the molten core. I know it kind of
I know another example.
Yeah.
Because, like the recoil on an actual gun.
Oh, like a combustion reaction.
Yeah, because the kinetic force of when you shoot the gun, it makes it move back.
Mm-hmm. Exactly, like with a combustion reaction, that's exactly right. It's very similar. It's like this big blast of kinetic energy. And the way that volcanoes get that is from heat energy, thermal energy, and then also pressure. So when there's lots of like really hot rocks, we think of rocks as being kind of stationary, solid objects, but rocks can melt, right? That's actually how we
With
get
a lot
glass.
of heat,
Yep,
so much heat.
exactly. We actually get glass that way as well.
You can also find, because sand is actually just little tiny rocks.
Mm-hmm, exactly.
And people say it's usually just sand that you get glass from.
Yep, you can melt sand down and get glass. That's exactly right. And it's really similar. Like in order for something to melt, it has to be exposed to really high temperatures. Different things melt at different temperatures, and rocks melt at very hot temperatures. And so the molten lava gets really hot, or magma, sorry, and then it explodes because it has all of that energy and it really wants to move around. Especially if there's like a pocket of air stuck in there, or if there's like a big amount of pressure, it's going to push all of that stuff out, and that's how we get volcanic explosions. But most volcanoes, when they explode, they're actually not that dangerous because they usually leak out lava very slowly. So that's not to make it
So
scary.
it gives you a long time to escape.
Exactly, that happens lots
The
of times.
only really too dangerous part is just the flaming rocks that come shooting out.
Yeah, that only happens when there's lots of built up pressure, though. So there you have it. This was our first Saturday Science, May 2022, studying the lithosphere. We did an acid-base chemistry reaction today to kind of explain maybe like the kinetic way that a volcano might explode. So thank you for joining us, and I hope you have a great day.